All right, good afternoon, everyone. Thank you for joining us for the last of the virtual field days that I've organized here for the Northwestern Illinois Ag Research and Demonstration Center in Monmouth. Today, our presenter is Dr. Nathan Kleczewski. He's our Extension Field Crops Pathologist with the Department of Crop Sciences on campus. He is going to talk to us about not only tar spot, so he's kind of giving us more of a general corn disease update.
So my name is Nathan Kleczewski. I'm an assistant research professor and extension specialist at the University of Illinois. And I'm going to be talking a little bit about some of the research we're doing here at Monmouth on tar spot of corn, or corn tar spot, as I like to call it. It rolls off the tongue easier. This is a foliar disease of corn that has received a lot of attention over the last 2-3 years, and that's because it's becoming more problematic in the corn growing regions of the United States, particularly here in the Midwest. It's a disease that first was described in Central America and Mexico. It's endemic to Mexico, the Caribbean islands, and parts of South America as well. And in 2015, actually, we saw for the first time tar spot here in the United States. It was confirmed in DeKalb County, a few other counties in Illinois, as well as out in Indiana as well. Since then, it's actually spread to 310 counties, I believe, across 9 states. So currently, in addition to Illinois and Indiana, it's found in Michigan, Wisconsin, Missouri, Minnesota, Iowa, Florida, Ohio. I think that's it for now. And we believe that based on the temperature and environment that we have here in the United States, that it's probably going to continue to spread further west and east. So it would not surprise me if we don't start seeing tar spot in the Dakotas, in parts of Canada, and Nebraska here, if not this year, in the ensuing years. So this is a disease that is caused by an obligate fungus. That means it needs a living host to grow and reproduce. So we can't isolate this out of tissues and grow it on petri plates or anything like that. It's much more similar to, say, a rust or a powdery mildew in that regard. It needs that living host to grow and reproduce. It overwinters on residue, foliage that's infected, or husks and stalks that are infected with the pathogen from the previous year. On that tissue, it actually produces these black, resistant or recalcitrant structures called stromata. Inside those stromata can be hundreds or even a couple thousands of spores, and those spores will be extruded when the conditions are appropriate, and they're actually going to be kind of rain splashed up onto the foliage of the plants. They can also likely move on air currents some distance based on some of our observations. So definitely going to see some field-to-field spread of this disease, and even maybe a little longer distance spread. After infection, there's about a 2-week window there where you won't see any symptom development at all. So you could be out in your field and thinking everything looks fine, and then all of a sudden you'll start seeing that pathogen, or those symptoms and signs of the pathogen will start to show up then after that 14-day latent period after infection. When conditions are conducive for disease, that's usually after our rows have started to close. We get the canopy filling in, humidity building, we get a couple rains. That's when you're going to start seeing this disease take off. And it does move pretty quickly. So it's one of these diseases that has this exponential phase where it starts really slow, but then it hits a certain point and it just takes off. And that has to do with the life cycle and the ability of the pathogen to produce spores. When we get to a point where we're seeing, say, 30% of a leaf with infection by Phyllochera matus, the causative fungus, typically what we'll see is that leaf will start to shut down and dry up, and you'll see this rapid senescence of the plant. Depending on when that happens, if it's earlier in the season and there was still a lot of grain to be made or something like that, you're going to see reduced yield. We saw 25, 30 bushel kind of on average yield losses in 2018 when we had a big epidemic of tar spot up in this region. You also could see some stalk lodging issues, again, kind of related to the impact that the disease is having on the carbon budget, because it's drying out those leaves. And your plant needs to get carbon from somewhere to fill the grain, so it starts pulling from the stalk, and then you get lodging issues. So right now we have a lot of questions about this disease because it's really, really understudied, and everything that we're learning is kind of new. So all the things I've mentioned here in this talk actually are either coming from research that have been done by us or our colleagues, or maybe some basic things that we've learned from the past. But we really don't understand a lot about the ecology and biology of the pathogen. We don't really understand much about resistance to the pathogen in our germplasm that we have here in North America. And we really want to learn how to manage and control this disease, and that's kind of what these trials here are set up to do. So here at Monmouth we have several different tar spot trials. One that we're working on right now is we're actually inoculating a nursery trial. And so my colleague Tiffany Jamin and her student Sarah have several hundred lines of exotic sources of corn and resistance in corn from I forget the name of the place. We call it GEM. That's the abbreviation for the entity. So we have several hundred of those, and last year we ran a study, not just in Illinois but in other states, assessing some of these different sources of germplasm for resistance. And we were able to find that there were, across trials, 5 that were consistently the best and 5 that were consistently the worst. And so that gives us good hope that we're kind of focusing in on the characteristics that we're searching for and the characteristics we don't want. And then what we can do is we can run some genomic mapping and screening and figure out what's similar or different about these and figure out where that resistance is. And then after we find that resistance, what we can do is develop tools or markers that could be used by industry or other breeders, other researchers, that can then track whether or not that resistance has made it into a new hybrid or something like that. So that's what we're doing here. So today we have a subset of our nursery. We're laying down residue, so we inoculate our trials. As far as the nursery goes, then we're going to be collecting, data on incidence and severity, and then that's gives Tiffany and her students some clues as to where to look for resistance. So that's one component of managing this disease. We don't know much about resistance. Everything we have that's currently available to us is going to be susceptible to some degree, and so what we want to do is really focus in on figuring out, what resistance is out there that we can use in our North American germplasm. How do we incorporate, how do we detect it, and get that information out to the public. So that's what we're doing there. Second bit of information you think about managing a disease that's residue borne is, well, what about residue management? And I did mention that this pathogen or this disease does tend to travel a little bit on air currents. We're not really sure how far, but we do know based on some observations that you're probably dealing with, yards to maybe a mile or two. The ascospores of this pathogen aren't extremely aerodynamic, so we wouldn't expect them to be moving extremely far, but again, we don't know. But because it does travel a fair distance, that means that residue management isn't likely to have a huge effect. It's not going to prevent the disease from coming into your field, but what it can do is it can minimize when the disease onset is within a field, because otherwise those spores might have to come from your neighbor's field or from down the road, and maybe the onset of those spores coming in is a little later in the season, so you buy yourself some time, and then the yield loss or damage is reduced. So what we're doing is, if you think about managing residue, you're probably talking about tillage. Well, doing tillage research is very difficult just because the implements and the size of the plots involved. Also because every tillage implement buries residue differently. So you might have some that only bury 5 or 10% of residue. You might have some that bury 80 to 90%. It all depends on what tool you have. So when somebody says utilize tillage, or we're doing a tillage study, it's really difficult to get good quality data out of that. And so one of the things that we're doing to kind of circumvent that issue is we're not utilizing tillage per se, we're actually manipulating the quantity of infected residue on the surface of plots, which allows us to have smaller plots and also manipulate the amount of residue. So again, the harvested residue from last year, we're actually spreading that out at 3 or 4 different rates into plots, and then what we're going to do is we're going to measure the amount of disease within plots, when it starts, how fast it moves, and then ultimately yield and quality from these experiments. And so we have experiments set up here in Monmouth and other parts of the state where we're looking at that. And then the third thing we're looking at, obviously, fungicides have received a lot of attention because currently that's the only thing that we have available to us that within the season, if you have an outbreak of tar spot, you can apply a fungicide. As I mentioned, this disease takes off and establishes and just blows up really fast. So you need to get that fungicide on right at the onset of that disease. You don't want to be waiting 3 weeks afterwards to make an application. So if you miss that window, that first window for application, and you come in 3-4 weeks later, it's not going to have as much of an effect as if you get it on before that infection occurs. But tar spot's kind of tricky. We're trying to figure out the exact weather conditions that favor when the disease will actually take off, because sometimes it starts very late in the season. Sometimes, like in 2018, it's earlier. It seems to be very much driven by water. But our trials here are going to be looking at some of that. So what we're doing is going onto these plants at different timings, different points in time, and we're also having a model-based application. So my colleague in Wisconsin, Damon Smith, was he's a really sharp guy, and he's really good at developing apps and working with epidemiology. So he's been able to develop some preliminary models for tar spot based on the data that we've collected the past couple of years. And we want to test that model out and see how well it's predicting the epidemic. And what that can do then, potentially in the future, once we have a model that is of high enough quality and we're confident in, that can be released to producers, and then a producer who, say, wasn't thinking about applying a fungicide, maybe they can, because the model says they're in a favorable condition. Or, if they were going to go on with a fungicide and the model doesn't tell them to spray yet, maybe they hold off a little bit on that to make an application. So tar spot's a bit of a moving target. We have a lot of other foliar disease that are problems for us, bigger problems than tar spot, but because tar spot's new, that's why it's getting the attention. So I always tell people, we're working on researching tar spot. We're going to figure out how to manage it, but we can't forget to manage the things that are issues for us from year to year. And that's things like northern gray leaf spot, those sorts of diseases. Up in the northern part of the state, we're not so worried about southern rust, but you get down in the south, southern rust is a big one on everybody's radar. So in terms of managing tar spot, right now, the best thing you can do is know the history of your field. Are you in a county or a region where tar spot's been detected? If so, well, then you have elevated risk of getting tar spot. If you have it in your field from last year and that residue is still on the field, bumps you up a little bit more. Planting corn, doesn't really matter what you plant because they're all kind of susceptible, okay? And then, if you're irrigating, actually, now I know we probably have like 6 pivots in all of this state here in Illinois for seed production and things like that, but as I mentioned earlier, this is a disease that really is pushed by wet weather. So if you're irrigating or over irrigating, you could actually be forcing the issue in some areas, and so you need to be careful there. But the best thing you can do is scout your fields. You want to be getting out there prior to tassel. That window between tassel and R2 is going to be kind of that sweet spot that you're going to want to hit with a fungicide anyway. But if you start noticing tar spots showing up in your fields just at VT or just prior to VT, that's going to tell you, hey, I got to get in here and make an application of a fungicide. Products to use are going to be labeled. There's several that have labels, and you want to be going with something that has a mixed mode of action. So you want to have something that has triazole, an SDHI, or a QOI or sobiolern, some combo of those, because our data kind of show that those are going to be the most effective for managing this particular disease, and they'll help you with your curative and residual controls as well. All right, well, I'll take off then with that. Thanks, Chelsea. And I forgot how much I rambled on about tar spot there in that in that talk. So that's good because some of that information I have in this talk, and I can just kind of skim through it and focus more on some specific slides. As Chelsea had mentioned, I mean, we filmed that several weeks ago, and over the course of the last 3-4 weeks, a lot of things have changed. And so one thing that I mentioned in that particular talk there was that people in the South are worried about southern rust. Well, I think a week after we filmed that, we started to see southern rust in the northern part of the state, and it's really kind of blown up in the northwest part of the state, actually. So that's it's kind of interesting how how these things work out and change over time. And that's why another reason why it's important to kind of stay on top of your fields and be out there looking at things, because a lot of these diseases are moving targets. So I'm going to talk a little bit about southern rust and corn tar spot. Of course, you just heard me rambling on about that. I'll go through some of that information again. I'll spend a little more time on southern rust. Southern rust is an interesting one because it doesn't often get up into the northern part of the state, or if it does, it usually comes in so late, it's really not an issue. But because of the situation this year and because it's kind of come in a little bit early, it can be a problem. It can potentially pose a problem for some of the producers up there. And so that's why we want to be sure about our management strategies for southern rust, how to identify it, and what options there are out there, and what you can do in subsequent years if that ever becomes a problem again. So southern rustic corn is something, like I said, it's something that we don't really see very often in the northern part of the state. It's caused by an obligate pathogen, so it requires a living host to grow and reproduce, and it's caused by this particular pathogen, Puccinia polysora. Now there's another rust that the common name is, it's called common rust. That's another one that we can see on our corn. That's not something that's typically going to be yield limiting. We see it early in the season and usually later in the season when conditions are cooler. You don't want to be mixing up the two, because southern rust is something that can cause significant damage to your corn. Common rust, on the other hand, is something that isn't going to be a major concern in the majority of situations. I like to always hedge myself there because there's always going to be one or two situations that it could be problematic, but by and large, it's not something that that's an issue for us. So southern rust is going to be found on your foliage, on the leaves. Occasionally, you'll see it on the husks and even the stalks of corn plants. Now, remember, just because you see something growing on the stalk does not mean it causes a stalk rot. It's just growing on that green tissue. It's not going to be actually rotting your stalks. What kind of conditions favor southern rust? And remember, I said we didn't have it maybe 3-4 weeks ago. So what has changed since then? Well, first off, this is a disease that likes it pretty warm. Okay, so it likes temperatures between 75 and 93 degrees Fahrenheit. Our colleagues in the South, where this disease is more common, they've said if it's humid out there, 100, 110 degrees, no problem. It can still keep chugging along without an issue. On the colder end, that's 75 degrees, maybe a couple degrees lower than that, it still can grow and reproduce. It's just a little slower. And that means that the disease cycle is going to be a little slower, that cycle from infection to production of new spores. It only needs about 4 hours of consecutive leaf wetness. So that means typically what is that? 4 hours isn't too much. That's about the types of dew that you might see on a typical night. If it's humid during the daytime and then it gets cool at night, you'll get that dew forming. But usually anywhere between 4 or 8 hours of consecutive leaf wetness is pretty optimal for this disease to take off. One other thing to keep in mind with this disease is that, as I mentioned, it's very similar to common rust. And common rust, as the name implies, is fairly common in this region, but it doesn't cause significant damage, as I mentioned before. So these are some ways that you can distinguish the two organisms from one another if you are in a field. First off, common rust is going to have red or brown
pustules on them. So if you look here at this particular slide, you have a common rust pustule here. It's kind of got that dark red look to it. The southern rust pustule is usually a little lighter orange to almost yellow in color and tends to be a little rounder as well. The pustules oftentimes on common rust, you can't really see this on this page, but often they're a little elongated versus southern rust where they tend to be very circular in shape, and they also tend to have a halo around them. The other thing that you can use, and again, there's always situations where this might not be true, but usually southern rust is going to be found on the upper surface of the leaf, whereas common rust can be found on both surfaces of the leaf. If a leaf is flipped over because of wind or something like that, then of course, whatever's facing the top can still get infected, or if it's kind of not quite parallel to the ground, you can also see that sort of thing occur. But by and large, you're going to see the majority of southern rust on the top of that leaf. Southern rust also tends to be very densely packed, so you see it in sections of the leaf where there's going to be a lot of it versus common rust, which is usually a little scattered. And then the big thing is southern rust likes it hot and doesn't do so well when it's cool, and common rust likes it cool and doesn't do so well when it's hot. So that's usually one thing that you can keep in mind if you're starting to see rust in the field is, well, what are the conditions been the last few days? Another thing you can do is, if you're handy or you have a microscope, is you can take your leaf samples home and you can look at those spores on a slide. And that's what this is showing here, is it's showing a combination of common rust and southern rust spores. And what this shows here is where that's pointing there towards that kind of oblong spore. It's yellow, and if you notice the outside of the spore is kind of clear, that's the spore of southern rust. The circular reddish brown spores that don't have that kind of halo around them, those are common rust spores. So you're going to look for something that's yellow to orange that has that kind of thick wall to them. They're going to be oblong. The common rust, very round in shape, a little smaller as well. So tracking movement with this disease is very important, and that's because this disease does not overwinter in Illinois. It actually overwinters in Central America and blows into this region as the growing season occurs. And the earlier it arrives in the southern states, usually that means if we catch a tropical storm, we catch some weather, it's going to blow up here. And the earlier it arrives, the more potential yield impact it can have. So if you have this disease moving in prior to tasseling, you can have some major issues, not just with yield, but also with standability. And if you get it taken off anytime between tasseling and R4, you're going to see potentially some significant yield losses occurring if it's widespread throughout your field. So as you can see in this chart here on the right, that's the incidence of tar spot. This was as of the 12th, so I think I've actually added a couple counties to this map. This is just showing counties where we found some tar spot. I'd say overall in the northern part here, that northwest section, there's definitely going to be some fields in this area that had some pretty significant levels of southern rust that were observed here early and have kind of been building over time. So it's going to be very important for you if you haven't been out in your field, especially if you got a late planted field and you hadn't been planning on any kind of management, say a fungicide or something like that. Go out there and check your fields and look for this thing, see where you're at, check and see if there's something you might need to do management-wise. Some of the things to keep in mind too are hybrid susceptibility. I spelled that wrong, susceptibility. But hybrid susceptibility is usually one of the management practices we recommend when we're talking about integrated management for plant diseases. One of the issues with southern rust is that a lot of our hybrids, especially as you get into the shorter day hybrids in the northern parts, and northern part of the state, in Wisconsin, those areas, a lot of them don't have very good southern rust or any southern rust resistance in them. And so what you end up with is a whole bunch of corn hybrids out there that are very susceptible to this disease. You get in the southern parts of the state, you can find some that actually are pretty good. But the key here is none of these are going to be immune. So they can slow the disease development. They can reduce the impact, but that doesn't mean you're not going to see any disease. It just means, okay, you might be seeing less disease over time. The other thing you have to understand when it comes to selecting hybrids is that some of these, actually quite a few of these hybrids that you're going to look at will be rated for common rust. And as I mentioned before, that's a different disease. And just because you have resistance to common rust does not mean you're going to have resistance to southern rust and vice versa. So make sure you're clear when you're looking at your hybrids, what you're looking at and what to expect from it. So these are just some examples I pulled offline of what some of these ratings might look like, where, you know, in case this one here was rated for common rust and there's no southern rust, some of these here have southern rust, no common rust, vice versa. So it's just an idea of what you need to be looking out for. Now, one of the big questions is, okay, maybe I've got southern rust in my field. What's the likelihood that if I spray something that it's going to pay? And this is something that's been kind of studied quite a bit in the South. And again, they see this disease a lot more than we do, and they see it in much more severe than we see oftentimes in the majority of our state. And they've kind of developed this little chart to kind of give you an idea of the likelihood that you're going to need to make an application and the likelihood that it's going to pay for itself. So whatever you put on, it's going to, at least whatever you make in terms of saving yield, is going to pay for that application cost. So the first thing you need to have in the field is southern rust. Is it present? Is it present at noticeable levels? So not just like one leaf in the field, but you're going out, you're finding it pretty frequently in the field. So it has to be present. Is it in that temperature range that we said is kind of optimal for development, between 73 and 95 degrees Fahrenheit? We're catching some humidity, maybe there's some storms going through, that sort of thing. If you're in that kind of vegetative to R3, maybe even that R4 window, then you might see a benefit of a fungicide application. You get past that R4 window, then it's going to be very unlikely that you're going to see a benefit from your fungicide application. And this is one reason why I said, if you have a later planted field, maybe you're just hitting, you know, R1, R2 right now, you're still in that window where you could see some significant issues if we catch some more rain up in the north part of the state. So it's important to keep your eyes out for this disease. One of the things that they've also done in the South, and I find this particularly helpful, is they've developed kind of a risk calculator. And this is just something that can help you with making a management decision. And so what you do here is, you've probably seen these before with other diseases, but you can take this out and you give yourself a score based on the conditions in your field. And based on that score, it can kind of give you, kind of help you out in terms of, well, what should I do for this field? So what I did in this case was I went through my Monmouth research plots where we have some fungicide trials. And I did this on the 12th for my fungicide trials. So I went through the temperature. It's been between 77 and 90 degrees. So I gave myself 3 points. Leaf wetness. We've caught a little bit of rain there over the last few days, and it's definitely been humid in the morning at 7, 8 o'clock. So I'm pretty confident we're getting anywhere between, 8, 9 hours of wetness. So I gave myself a 2 or a 3 in there. And then the storm intensity, it's kind of been off and on, but overall in Monmouth over the last 10 days, there's kind of been this intermediate rain or wind. So I add all those up, and I'm at a 6 to 7, which in this case would be putting me here with the with this condition where we might be wanting to make a fungicide application. And so that's just kind of how you could run this exercise through if this is something that would interest you. And I certainly can make this available. But again, this is something I have also posted a link for this on the field crop disease management blog that I write up as well. And so you can access this there. Now, in terms of fungicides, what kind of damage, what kind of issues can you have with southern rust? This is a trial that we ran last year in, oh gosh, where was this? I forget. It was in the very southern, Carmi. This is in the very south part of the state. And in this case, disease was just starting right at tasseling. And this is a field that was irrigated and also caught a few extra rains. This is kind of a perfect storm. It was also a very susceptible hybrid. And as you can see here, even though the disease was present at a low amount on this date, about 46 days after application here is when we started rating it. And our non-treated checks on that ear leaf right here, we had about 12% disease. That's a pretty substantial amount of disease. If you saw that on your leaf, you'd say that's probably quite a bit of southern rust. So at this point in time, you can see we're getting some control of tar spot. Anything that shares the same letter here is statistically similar. I make those all yellow here if they're similar to controls. And then if they're different from the controls, they'll have different letters, or different from one another, they'll have different letters behind them. So here you can see that we're getting a reduction with most of these products on that ear leaf. And then if we look here, 58 days after application, look at how fast this has taken off. It's gone from 0.5 here on this date to about 12% 46 days later. But then another week or two after that, and we're up to 36, almost 40% disease. And these leaves can't handle much more than that. They'll just totally shut down. So you can see the application of a lot of these products, even at VT, still resulted in a significant reduction in southern rust on these leaves. Obviously, some did a little better than others, but you know, they all helped out a little bit. The exception being these kind of cheaper, older DMI chemistries here, the tebuconazole, propiconazole type products. And then what we also saw is a pretty significant yield response here as well. And I like to point out that there was northern corn leaf blight in this trial as well. That's kind of somewhat confounding these results, but we are seeing some really significant yield swings here in this particular trial. So if it comes in and the conditions are right, an application of a fungicide can definitely improve your situation when it comes to yield at the end of the year. That being said, what's the take home with this disease? First off, know your hybrid. Keep in mind, most of your hybrids are going to be pretty darn susceptible, but maybe you got lucky and you planted something that has a little more resistance to it. That's important to know because that's going to reduce the likelihood that you're going to see major impacts from the disease. We definitely need to be out there scouting our fields. I know just based on what I'm hearing and seeing, there's a lot of people out in their fields this year, just like last year, and that's great. But we want to make sure we're going from tassel through R4 or so. And the other thing is, if southern rust is detected, you know, you want to be making sure that you're checking your growth stage and kind of weigh your options. Run through one of those calculators like I showed. Kind of use that to help you make a decision whether or not it's something you absolutely have to do or not. And if you are going to make an application, it's probably best to go with a premix fungicide. It doesn't have to be something that would break the bank, but try to go out with something that at least has two modes of action that'll give you the best curative and residual activities. So anyway, like I said, we already went through a lot of tar spot stuff, so I'm not going to move into this too much. I already went through a lot of this information before. These are some great images of what tar spot can look like when it's severe. So those of you that are going out right now and you might only be seeing a couple of leaves in the lower canopy or mid canopy and it's kind of scattered, this is what it can look like. And this is what it looked like in 2018 or so. Definitely tearing up the plants a little bit. It can look like a lot of different diseases. One thing that you want to do when you're diagnosing tar spot, look at how those spots look on the leaf. They're going to be very black, but oftentimes they kind of have an elliptical shape to them. They kind of follow those veins oftentimes. As you can kind of see that here, they almost have whiskers on them a lot of times. And you're also going to be able to see them from the top and the bottom of the leaf. If you do see black spots, that can be other things like physoderma, or this one's probably the biggest one, insect frass. What you want to do if you see these black spots kind of sporadically in your plants is just get them wet and try to like wash them off between your fingers. Oftentimes that's going to be the sign of insect frass. Also, you're not going to be able to see this or even the physoderma on both sides of the leaf. And the physoderma on the foliage is going to be just on a couple of leaves, and oftentimes it shows up in bands. I talked through some of this already. when it comes to hybrid selection, just keep in mind that, kind of temper your expectations. No hybrids have been purposely selected for tar spot resistance yet. So anything that's there is there kind of by chance. We definitely don't have anything that's immune, but we do know that the relative susceptibilities differ. So you can go and you can ask your seed dealer, what are if they have any data on tar spot, and maybe go with something that has, less susceptibility to tar spot, and that can help you out as well. There's also a lot of different fungicides that are available right now for tar spot. So this list has increased greatly since 2018. One of the things I mentioned here when it comes to managing this disease, similar to southern rust, is you probably want to be going with a chemical that has at least 2 modes of action in it. That can help you on the back end with residual, and also help get that chemical into the leaf fast if you've got an epidemic kind of just starting on your plants. The disease moves really fast. That's what this is showing here. For looking at the development over this period of maybe 10 to 15 days. It went from 3% all the way up to 35% here in Illinois. So it's really important to make our applications at the start of an epidemic. And those applications can definitely help us out, especially if we have a susceptible hybrid. So here we have, in this case, a field that was non-treated right next to a field that was treated. We have 5 different hybrids. These 2 here are less susceptible, so those fungicide applications had less impact in terms of the amount of tar spot on the ear leaf. But those really susceptible ones, you can see it was taking it down from 40% down to less than 5 with a good timed application at VT in that year. So it can definitely help. But some of these, again, will have longer residuals than others. And this is another reason why we say try to go with something with multiple modes of action. In this case here, what you can see is the tilt product on this particular trial. Even though we applied it here at the 18th of August, we started to see tar spot on the 12th of September. Those products just run out of gas, and they don't do as well as some of these other ones later in the season relative to our non-treated checks. So going with something with multiple modes of action. The other thing with timing is to keep in mind that, if this disease comes on late, say R5 or so, you probably don't need to be making an application. It's going to be, I think, similar to southern rust in many regards, where it's between that VT to R4 window. In this case, we made an application at R5, and then we came back and rated it. And what we saw was a significant difference in our senescence. Our senescence was reduced relative to our non-treated checks, but there weren't any impacts of lodging. And sure, there was a difference in disease, but that wasn't something that was really significant or translated to yield. So in terms of managing, this is what I was mentioning before. Scouting is important. Managing your residue is going to be something to consider. A lot of people, that means rotating to other crops for a year or two to break down that corn residue, although you might still get disease. Consider fungicides, but you don't want to do revenge sprays. So if you have a significant amount of disease and you just spray it on there, it's not going to make things better. It might make you feel better. And you need to, if you do have an application, it's going to need to occur close to the onset of the epidemic. So that means getting it on there at the right time, and that means you need to be out there in your field scouting. So that being said, I think that's more than enough information for you here, and I'll just go ahead and stop with that, and I can take any questions you might have if you have any.
Here's a question.
Mm-hmm.
Nathan, how would you describe the current level of tar spot outbreak in Illinois compared to 18?
Well, it's not as severe as in 18. So if we think about what happened in 2018, and I can remember this, it was showing up in Illinois. We first started to see it in late June. And then by the end of July, it was pretty noticeable. And then we had that huge tropical storm that just kept pushing wet weather through the end of the season. And so by VT in most fields, entire plants up through the top of the canopy were infected. Right now, the timing of the disease is about 3 to 4 weeks later. We've had a couple of hot patches of weather that have slowed it down. So in general, we have a lot less disease right now. It's a lot not as widespread. It's definitely starting to pick up a little bit, especially in the northwest part of the state. but by and large, I'd say we're not going to see widespread issues with it, but we're probably going to have some situations in some grower fields where they might have to consider making an application. So I'm not saying we're out of the woods yet, but we're close in most situations, but it's definitely not the situation it was in 2018.
All right, and we've got another question here in the chat. When you say to make fungicide applications at the beginning of the epidemic, at what level of leaf coverage by number of spots per leaf do you call the beginning of an epidemic?
That's a really good question. I don't have a specific amount. For me, it's going to be more about where you're at in development and how frequently you're seeing that disease in the field. So, for example, a lot of times you're going to see this disease start in the lower canopy. If you're seeing it kind of consistent at the lower canopy at a level where you don't have to bend down to find it, and it seems to be pretty high in terms of incidence or the number of plants, then you might have to come in a little bit later and make an application around tassel or a little later. If you just see one or two stroma and you're at the R4, R5 stage, that's not something that you're going to have to be worried about. The big thing to keep in mind here is that it doesn't take a lot to get going, but you still have some time before you see that really big explosion of disease. And so you kind of want to hold off until you start seeing that disease at a noticeable level and then try to get it on at that point. So it's not an exact science yet. That's where having a model system will be useful, but that's something that's probably going to be a ways away from being really available where we're super comfortable in that system.